And our first lightning talk we have is B.J. Neal from the FCC, who's going to talk to us about the National Broadband Plan.
Okay.
B.J.
Thank you. Hello, my name is B.J. Neal. I'm from the Federal Communications Commission, and I'm on the National Broadband Plan team. Everybody relax. I'm not a lawyer. I'm not here to regulate or otherwise enforce any rules or any such thing, but I've come here to seek information from you guys, the experts in network engineering and operations, and looking to get some input from some of the membership here on about how we at in the FCC and the National Broadband team should look at traffic engineering and sizing sort of the backhaul and shared portions of the network. A little bit of background on the National Broadband Plan. For those of you who are not familiar, early this year, the President and Congress tasked the FCC with putting together a plan to provide a framework for broadband access to all Americans, focusing on rural, unserved, and underserved areas. So the Commission is committed to fulfilling this plan and having it delivered to Congress by February 17th of 2010. So time is pretty short for us to get this plan put together. So that's one of the reasons I'm here seeking information and trying to make sure that the plan is data-driven and not motivated by political factors and such, but the Commission is committed to making this a data-driven plan. So that's one of the reasons I'm here, trying to get some real-world numbers on how we should think about sizing portions of the network. So there's three basic components to the broadband team. There's a deployment team, the national purposes team, and the adoption team. I am actually on the deployment team, and what we are focused on is looking at what technologies are we going to use in some of these areas for access, such as cable, fiber to the home, DSL, 4G wireless. So all those things are being studied and modeled from a cost analysis perspective on how we can drive broadband out to the underserved and unserved folks. So, we're concerned with what would it cost to deploy these various technologies or upgrading them such that they would be acceptable for a good broadband service for consumers. We're also looking at what funding sources would be available throughout the government that would enable deployment of broadband, and what sort of policy levers should the FCC look at to either change or enhance to further encourage deployment of broadband in underserved areas. There's also a national purposes team as part of the team, and they're concerned with making sure that the plan considers healthcare, hospitals, schools, other public institutions, smart grid, and things of that nature. We want to make sure that as part of the plan that we address those things, which is something important to national security and goodness, general goodness. And the third portion of the team is the adoption team. That group is focused on trying to understand what we need to do to encourage users in some of these unserved and underserved areas to actually adopt broadband. It may be that certain folks that are unserved cannot afford computers. It could be that they have inside wire problems in multi-tenant units and multi-dwelling units. It could be that they need education, things of that nature, to make sure that while the deployment team tries to look at getting broadband to the masses, how do we drive adoption further? And again, one last comment that it's important to note that we're trying to be data-driven and develop the plan through the use of facts as much as possible. So no presentation or slide deck is complete without some sort of diagram. This is for your entertainment. This is the one I put up here for this presentation. But really the reason I brought this up is to give you an idea about how we sort of think of the different portions of the network. sort of on the left side of the diagram are the different access methods: wireless, DSL, cable, HFC, fiber to the home, fiber to the prem. The second mile access, and then there's middle mile access in the core internet. Not sure why we use these terms, but the second mile and middle mile terminology seems to come up quite a bit in public notices and other filings that operators file with the Commission. So we're sort of using this terminology. I hope you'll forgive that. I wanted to give you a little bit of idea about what we mean by that. So for second mile access, for example, that might be sort of the metro portion of the network between a central office and maybe a DSLAM remote terminal. It also could be viewed as something like between a head end and a cable node, for example. In the case of wireless, that would be between the actual cell tower and the actual aggregation point, where there may be some larger capacity fiber facilities available. And when we think of the middle mile, we're thinking between, say, a central office back to some larger tier city where an operator might need to get dedicated internet access service from a larger provider for internet transit. So, in rural areas, there's some pretty significant cost factors associated with some of this backhaul or middle mile access. These links can be very, very expensive in some of the more rural locations. So, if you're thinking if we're thinking for example, someplace in rural Arkansas back to Little Rock, for example, or someplace in rural West Virginia back to Pittsburgh, those backhaul portions of the network can be very costly. So that brings me to the point of why I'm speaking to you guys is I want to try to get a view, and we want to make sure that we consider how we should think about engineering those links or the traffic portions of the shared network going back to the transit point on the internet. So how should the broadband team think about traffic engineering or sizing these backhaul portions? Obviously, I mentioned the significant cost of such links on the previous slide. Last night, while I was I was actually gathering data at the beer drinking function last night, and one of the fellow network beer drinkers said, "Well, you know what you're looking for is an Erlang model to describe the public internet traffic mix." And I think that's right. I said, that's exactly right. That's a good way to sort of state the problem. I think it's a simple question, and it's a simple problem with it's a simple question with a very difficult answer, has many aspects and many different attributes to trying to size internet traffic given growth and the burstiness and the bursty nature of that traffic. So there's no way we can use the standard voice Erlang model and just apply that to internet traffic, but I'd like to think that there is some way to sort of use some sort of formula to sort of calculate the dimensioning and sizing of these portions of the network. Yes, it's difficult, but I think that many of the folks in this room do that every day. And so what I would like to do is talk to as many of you as I can to see if you could share with us some of your views and principles on how you view traffic engineering for public internet traffic. So I'd be happy to take any questions if anybody has any questions or concerns about this. And if not, thank you for your time, and look forward to speaking with many of you about this for the duration of the conference. So thanks a lot.
Randy Bush.
Oh, I'm sorry.
Randy Bush, IIJ. It's fun visiting a third world country here. But to answer your questions, I live in Tokyo, you just have fiber, and we have problems in the last 100 meters because the riser in the building's only 100 base T to each, and I can get 80 megabits with highly tuned TCP from my apartment to the West End in Seattle. So, and I also happen to have a third world connection in Seattle from a house there, and I can get almost 600 to Seattle Weston from there. It's only a couple miles, and it costs me 3 times as much per month. So it's not very amusing. As far as how to do traffic engineering, provision it, and you don't have to.
Can you expand on that a little bit further? I'm not sure I understand what you mean by that.
Over-provision.
Well, that's one way to look at that, right? But the over-provisioning comes with a fairly significant cost, especially if we're talking about having to deploy new fiber or trench new fiber in some of these more rural areas. It's very expensive.
Were not those similar words not used getting near 100, 70 years ago when we were doing the rural rollouts of telco? And in fact, down on the farm, we get darn upset these days if we get a circuit busy. So.
Agreed. Thanks.
Hi, Igor with Yahoo. I think we have a terminology problem here. I have a feeling that what the rest of us in this room call traffic engineering is not what you call traffic engineering.
Okay.
I think what you're asking for is how do I plan how much I provision? Is that accurate?
Yes, I think that is accurate.
Okay. To us, traffic engineering means I have this much traffic. How do I send it from point A to point B through which pathways? So if your question is how do I plan how much I provision, that's a completely different answer. So what exactly is your question?
So to use another vague term, I'm trying to look for what would be the formula to look at an oversubscription ratio, if you would, between a given group of users for a given set of applications that they may be using versus the backhaul portions of the network to the public internet transit point. So I'm basically looking to see what sort of formula should we use to calculate oversubscription ratios in the shared portions of the network.
I think the answer from most people is going to be that you actually build to what you need. Mm-hmm. And yes, you have a question of what you start with, but once your traffic starts to pick up as you add customers, you keep increasing to whatever they use.
Certainly.
And I think there's going to be a couple of access networks that may or may not be willing to share you what their initial numbers are.
So if you were going to build an access network from scratch, let's say, and you had a given number of users, I mean, the question is, how should we budget, for example, the cost of providing those links to these aggregation points? So not having the benefit of actual traffic to look at the FCC as we do this model, we're trying to build a model as if we were building the network from scratch.
And we've got to close the mics at this point, so I think we got either 2 people in line or 1 person in line. I'm not sure if Chris is in line or not. Braz?
So I think the key point here is the backhaul from your lower tier cities to where you really want to connect to on the internet is actually really cheap. It's really, really cheap and easy right now to go between major locations. 90% of the cost that you're looking at, it really is the last mile. So I would say build your backhaul with as much capacity as you need, and as far as budgeting, what's going to happen here, the way that it always happens, is when the government is buying stuff, they're going to get really, really bad deals. So you may just be screwed no matter what you do.
That's encouraging.
Yeah, but really understand that the vast majority of the cost really is the last mile. It's not, coming back on an OC12 or an OC48 or a 10 gig circuit. Those things are ridiculously cheap right now.
All right, thanks a lot.
So, Jay Moran, AOL. I have one more comment there. I'm on the BTOP reviewer committee. So we're looking at a lot of the different broadband proposals coming from various folks. And almost in all cases, it's somebody that's already providing some level of last mile transit anyway. So I think those folks can tell you what the adoption rate is and what their planned adoption rates are and what they're currently providing for different rural areas. So I think we probably already have it. We just need to ask the question of those people who are submitting applications to at least the BTOP program, which I'm assuming you're associated with in some way.
At some level, I'm not directly associated with the NTIA and those who are reviewing the VTOP applications, but yes, that's a good point, and those are some folks that we probably should be talking with as well. Okay? Thanks.
And next up, get the right one here, just for variety's sake. Next up, we have Matt Butak from Yahoo on IPv6 backbone deployment.
Okay, so this is actually going to be more of a sort of rah-rah pep talk than an actual like deep technical dive or anything like that. You've heard a lot of talk already being mentioned about IPv6, the policies, and some of the discussions that the ARIN meeting is going to be having. Earlier this year, I had the fortune to attend the IPv6 Implementers Conference over at Google. Heard a bunch of people talking about IPv6, saw a bunch of really good stuff on the slides there. When I got back, my mailbox was pretty much full of, Google says IPv6 is easy. And the kind of underlying question that was in the middle of that thread was, well, if it's easy and Google's done it, why haven't we done it yet? So the challenge was kind of tossed out there at the IPv6 Implementers Conference that, well, people aren't really deploying IPv6 because, you know, there isn't really that much content out there, and so there's not a demand. And when more content's available, then more people will demand it. Since the folks at the conference there presenting made it sound like it wasn't really all that hard to deploy, we figured it's probably time for us to really start diving in a bit more seriously on it and see if we can't help out on providing some of the content side of things. Earlier on, we'd made the transition on our backbone from running OSPF version 2 over to ISIS. So we already knew we were pretty well squared away for supporting IPv6 as far as our IGP was concerned. Most of the areas that people mentioned during the conference that were pain points for them tended to focus on things like support systems, tools, educating their user base, educating their engineering base, and dealing with old hardware and old software that didn't support v6 very well. One nice thing about being a relatively homogeneous, semi-enterprise looking entity is that we didn't really have to worry about as many of the end user education pieces, and we pretty much had control over which hardware and software we were dealing with on network elements. So we kind of set ourselves a goal and said, all right, we've got the joint NANOG and ARIN meeting coming up in October. It's a long enough distance away. Let's see if we can't actually get some IPv6 up and working. We set ourselves a couple of kind of hard caveats that fundamentally, for example, we couldn't break existing services running on IPv4. That just wasn't an option. Network had to stay up and running while we were doing this. We didn't want to take kind of a parallel paths approach where we would build a parallel network and put IPv6 on that and then someday talk about merging the two or integrating them. We really wanted it to be native, dual stack, just direct on the same hardware, direct on the same links. We didn't want to kind of cheat and do 6PE or tunnel overlays or anything like that. And we said pretty much from the operational standpoint, we can't break existing tool sets. Our monitoring infrastructure has to stay working while we're doing this. We can't have the NOC looking around, scratching their head saying, hey, did the backbone just disappear or what happened? And then the security guys kind of piped up and said, so you're going to add this new protocol to things. We need to make sure that the security pieces are thought of ahead of time. We can't exactly have this be a great new backdoor for people to get around the existing security models. So had to take those into consideration as well. So we kind of started putting together a plan. Biggest thing that really was kind of the gotcha, IPv6 addressing, really you have to approach from thinking about it in a completely different mindset. In the v4 world, it was always patchwork. You get what you can, you burn through it, you go back, you ask for some more, you duct tape a piece here and there if you have some extras you can use from locations, but it's really hard to do a long-term V4 address allocation plan. With V6, we really wanted to get it nailed down from the get-go and have a plan that we knew was going to work for the next decade or two of the company's growth. We wanted to have an initial test bed while we were putting the plan together where employees, the network engineers, could get comfortable with V6, and we could do some internal training and testing of stuff before we actually started poking at the backbone itself. As much as possible, we wanted to take human fallibility out of the picture, so we wrote scripts to automate the allocation of the IPs for all of our loopbacks, all the internal links, all of our peering subnets, all the data center blocks. In fact, pretty much everything V6 that got stuck on the network was actually generated by scripts and then pushed out, rather than counting on humans to count the right number of colons and things like that in the addresses. Likewise, we used scripts for generating config snippets for all the V6 backbone link interface configs, the IBGP sessions, configuring the loopback ACLs, and then we wrote scripts to go through and validate the V4 versus V6 IGP topologies. Since we decided to run single topology for ISIS, we didn't want to have any odd little black hole spots in the network where there's a link with ISIS running on it, it's got V4 on it, but for some reason the V6 address got left off. And once we had all the pieces together, we said, all right, well, that'll just be the make it so moment. Push the button and turn on V6. So in terms of the timeline we had for this, we'd already kind of put together our initial internal test bed, and that was just 2 routers with 6 PE running between them that engineers could log into. Didn't really have much on there other than the one link between them, the 16PE tunnel between them, and some addresses on it. But it let people actually look at an interface with IPv6 configured on it and, you know, do a little trace route and go, look, it's a V6 trace route between 2 routers. The other big thing that let us do, though, was start doing vendor testing on software platforms. Next piece, starting kind of earlier this year, in fact, pretty much right after the IPv6 Implementers Conference at Google, we really started work on nailing down the V6 address allocation framework. Again, we really wanted something that was going to grow with the company, something that we could lay down once and not have to rip out or redo again in 2 years, 3 years, 5 years. Once we got that piece nailed down, we continued working on checking on router software. It turns out that you'll hear a lot of things from vendors about how V6 ready their code is. You really want to test it yourself, because what they have in their test lab isn't actually going to match the sort of traffic patterns and sort of usage you have in your environment. So make sure that you're actually comfortable with a version of the software that the vendor says runs V6 and not just take the first GD release that they send to you. Once we were all squared away and had a good working version of code that we'd rolled out on the backbone routers, we actually needed to plan the V6 rollout. So August 10th, we had a 2-day meeting. A bunch of us got together in a room and said, all right, let's figure out which CMRs, change management requests we're going to need to do for this, which nights we can do maintenance on it. We didn't want to burn out engineers. We wanted to limit how much work each engineer was going to have to do on it. Put together the plan. On September 14th, we put the first link on, tested it for 24 hours, made sure nothing blew up. September 16th, we threw new ACLs and loopback addresses on half the routers. 21st, did the other half the routers. 23rd, we did half the links. 28th, we did the other half the links. So far, nothing blew up. On the 30th, we ran the V4, V6 congruency checker. We made sure that we had no missing black holes. Actually turned out to have 3 links with problems. Fixed those, reran it, 100% congruency. On the 5th, we pushed out our V6 policies and the IBGP to half the routers. The 7th, we did the other half. And then last week, we put up IPv6 peering addresses at all the major public peering points worldwide. So pretty much kind of a month start to finish, rolling out V6, didn't blow up the network, V4 stayed up and running. Wasn't nearly as bad as we thought it was going to be. In terms of major takeaways, though, testing. Testing is really crucial. Make sure that you test your router vendor's software with the particular functionalities that you need. Don't just trust marketing slides. spend the right amount of time coming up with a good address allocation plan. You don't want to just start with the first /64, go to the next one, go to the next one, and then find out in 3 years that you had nothing sane in your address plan. And do some scripted validation checks. Don't just throw it out there and hope and pray that it's going to work. Actual deployment time to roll it out, about 4 weeks. This is on a worldwide network covering 3/4 of the globe. From the backbone perspective, IPv6, it's not really that hard. Don't be scared. The time to dive in is now. If you're going to go to the microphone and ask me about data center pieces, applications, and actual content serving, that's a lot harder. Thanks again to Lorenzo, the guys at Google, and everybody else at the IPv6 Implementers Conference. Thanks again to Mike, Martin, and everybody else behind tunnelbroker.net. That rocks. If you haven't signed up, sign up now. Start learning about V6. And thumbs up to vendors that put V6 in their base IP packages. You're doing the right thing. Boo hiss for vendors that think that IPv6 is something strange that needs a special variant or special train of software. This needs to be ubiquitous. It needs to be out there. IPv6 is just like IPv4. Don't make it something special and separate. Thank you.
Thank you. Thanks, Matt. And okay, well, we got one question, and we're going to close the mics immediately because we're just a little behind.
Hi, Kathy Aronson. I just have a really quick question. It wasn't clear to me, are you running V4 and V6 in the same ISIS, or are you still running OSPF?
Same ISIS, single topology, V4 and V6, yes.
Okay.
Everything is dual stack native. Thank you.
And next up, Eric Westrow on BGP bots. This is an intriguing one.
Hi, I'm Eric Westrow. I was an intern at Merit Networks this summer, and for 1 week we worked on BGP bots, which is an IM-based route view bot. So route views, if you're familiar with them or not familiar with them, to tell you anyways. It's generally like a web or telnet based, so you can go to, Hurricane Electric runs one, AT&T runs one, most big ISPs run one, and you can type in these commands, and you can get their routing table and see, sort of how they see the internet, how they are peered, and how they're going to send packets to particular IPs and all that. But the disadvantage of these telnet and web-based ones are that you have to remember these non-standard IP or non-standard domains. Guess you could bookmark them, but who has time for all that? And then also, it's done with more, and I don't really like more. So, yeah. So we made this one. It's IM-based, and you just add it to your buddy list, and you can talk to it whenever. It's up all night, and just type in the command, similar command interface, gives you the results back. And to solve the more problem, it'll give you a link right at the bottom if it's too long. So it doesn't like flood you or anything weird like that. And then you can just click on that, and that survives for an hour after you type that command. So you can show it to all your friends for 1 hour. So the commands that we implemented are pretty much standard commands as far as we know, and we added some extra ones. Show IPBGP for IPv4. We added IPv6. We have 2 views that have IPv6. Then we just added some other, grab bag, network tools, ping, trace route, AS lookup. AS lookup is you can either enter a name like UMich or Merit, and it'll give you, or try to give you the number associated with that, or you can give it the number and it'll give you the name. So it goes both ways. Whois for IPs. It just queries the RADB database, Whois database. And then we also added grep, which is something that the other interface, telnet and web interfaces didn't really have. So you can pipe it through grep just as standard interface or standard command line as you're used to in Linux. So we did this in Python. First implementation actually just exec'd whatever you sent it, which was a bad idea. And so we fixed that and then made it a little bit more complex, but it's still pretty simple. We have 2 sort of protocol libraries, one for AIM and one for Jabber or XMPP. And every user per protocol gets a single thread, and then that interfaces to the actual VTYSH, which does all the, make sure you're not trying to rm-rf/ and all that. And so we left it up. We spammed out an email to NANOG, and a lot of people, we got a lot of good feedback, got a lot of good ideas, and added a lot of features. So here's the results. So 400 unique people, and that's pretty much the split. The Jabber was kind of down for a couple weeks, so this might be kind of weird, and it might even out to 50-50. And then as far as commands go, by far the most popular command was the show IPBGP command. So congratulations, show IPBGP. And so yeah, that's pretty much it. I'm going to do a demo real quick of this live demo. Yeah. So I said I was an intern, right? You know. All right. So here's my Gmail. I'm talking to BGP bots. Hey. It works. It's great. All right. Let's say I want to see. I'm not able to get to this IP. It's down or something. 214.1.2.3. I'm going to find out some information about it. Oh, okay. So here's the AS path here. Goes through AT&T. Well, if you didn't know, it goes through AT&T. The first one's 7018, so I can say AS lookup 7018, and it will tell me that's AT&T. And it ends in 2764, and that's Department of Defense. And if you wanted to know how many ASs does the Department of Defense have, well, so you can click on that link, and it will open here. Sweet. And they have a lot, as we would expect. And so if you wanted to see a whois, you just do the same thing with the IP. Pretty straightforward. You can trace route, which is actually pretty fast, I think. So you can see us using traceroute NANOG with the AS numbers in there, which is kind of helpful. And we also have IPv6, so Switzerland, and I don't know where this other one is, but you can query the entire IPv6 routing table, which is pretty small. So that's it. Does anyone have any questions? Oh, wait, one last thing. So we're still looking for views. Oh, okay. So we're still looking for views. If anyone has any, we only have 2 non-merit ones right now. So if anyone wants to provide them, just go to our website. There's an email there where you can send your interest, and we can get in touch with you that way. And also the source is available, so if you want to run your own because you don't trust us for whatever reason or something, you can take a look at it there. It's also on the webpage. So yeah, and feel free to talk to it. That's it.
Hello.
Yeah.
This is Patrick from Akamai. I was wondering if you had considered doing in-adder resolution for the trace routes, because I don't know what IP addresses are most of the time.
So you're talking about reverse DNS? Right?
Yeah.
Okay, so we thought about doing that, but the reason we don't is because it sort of makes it slow. And we kind of wanted it to be pretty quick because you only get 1 thread per user, so if you're waiting for it to reverse DNS resolve, 20 IPs, it kind of could take a while, so that's why we didn't do it.
Traceroute-N or something?
Right.
The opposite of what really happens?
Right. Yeah, so if you want to, add more specific implementations and whatnot, the code is available, and you can run your own version and all that stuff. Yeah.
Matt Petak, Yahoo, would you consider adding it to other messaging services like Yahoo Messenger, MSN Messenger, things like that? Yes, the 2 ones not listed up there are federated together. Thank you.
Right. Yeah, that's a good question. We just did these 2 as a preliminary thing, but if there's interest, the module itself is pretty basic as long as you can provide a Python module that can send and receive a message, and also send typing events if you want to do all that crazy stuff. If you can provide that, or if someone provides that, then it's really easy to tie it into the BGP bots.py itself, so you don't have to reinvent the wheel for that.
Excellent. Thank you.
Yep, thank you.
Thank you very much. That's a fun idea there that I must admit had never occurred to me.